Hello everyone, welcome to the next session on Advanced ANSYS Workbench tutorials. In this session, we will analyze a 90-degree bent pipe for its static structural analysis. We will start by double-clicking on Static Structural module. First, we'll go to Engineering Data and double-click. Engineering Data Sources. The material which I'm going to use for the pipe is say stainless steel, so I'll go to general materials. I'll select stainless steel as one of the material. Again, I'll click on engineering data sources and add another material which is CPVC. I'll select the first property as density, which is 1650 kg per meter cube. Next property which I'm going to add is isotropic elasticity. I'll double click on it. Young's modulus value is 3.1 gigapascal, so E9 because I'm writing in terms of Pascal. Poisson's ratio is 0.386. Now I'll go to project, update project. Next I'll go to geometry and right click. Since I have the geometry made, I'll directly import the geometry. Then I'll go to model and double click. I'll first go to geometry, solid. I'll change the material to stainless steel. Next I'll go to mesh. I'll give the element size as 0.01 in meters. So I'll change this unit to meter, 0.01. Then I'll go to generate option. Next I'll go to static structural and right click and insert fixed support. I'll choose the face option. This side is fixed. Internal surfaces I'm going to apply pressure, so I'll select them by pressing the control button. Again right click, insert pressure. This value I'll give in terms of megapascal, so I'll change the units to millimeter. I'll give the value as 1.52. Next I'll go to solution and right click, insert deformation total. I also want to see the deformation directional. Now I want to see along the Z axis, so I'll change this to Z. Also I want to see on this internal surface, that is what is the deformation along this bend. Apply. Again I'll right click, insert deformation directional. I'll change the direction now to Y and face will be this internal face so that I can see it on the bend. Then I'll right click again, insert strain equivalent. I also want to see the stress equivalent. I'll go to this option such that I can get the factor of safety. So I have just clicked on stress tool, maximum shear stress. So once this is done, I'll go to solution and solve. So now you can see here, this is the total deformation. If you want, you can go to edges and remove the wireframe. Go to contours, select smooth contours so that the colors blend into each other. And now you can see here the maximum deformation is 0.5352 mm over here. And in this zone where I've given fixed, it is going to be 0. You can animate and check this result if you want. Next, I'll go for directional deformation along the z-axis, and I want to see the deformation over here at the bend. So you can see maximum is 0.03 mm here, and minimum is minus 0.182. If you want to see max min, you can click on these two options. So now you can see this is max and this end is min. You can also animate and check this result to see. Then you can go to deformation 2, which is along the y-axis, which is the vertical one. So now you can see the deformation maximum and minimum. Maximum is shown as minus 0.038. Minimum is shown as minus 0.29 mm. At these points, you can see the value has changed and so has the position. You can also animate and see this one if you want to. Now we'll go for equivalent elastic strain. Again, you can see the maximum strain is here because it was fixed. This end is minimum. You can animate and check this result as well. The value is 0.000722, which is maximum, and minimum is 1.399 into 10 raised to minus 5. Then we'll see the equivalent stress. Again, maximum is here because it was fixed. Value is 139.36 megapascal. Here it is minimum 2.2728 megapascal. You can animate and check this one as well. It will give you the same sort of animation. Now what's important is the safety factor. You can see here the safety factor is minimum here, and here it is maximum. Maximum is shown as 15. It's actually the range of 10 to 15 in the zone. Here you can see it is little bit less. And wherever it is orange, you can see the range is from 1.48 to 5. And where it is critical, it is between 0 to 1. So these are the values which you can see from this pipe. Now this will help you understand whether the pipe is safe under this pressure or not. If it is not, you will have to work for a lower pressure for these pipes. Now the material used was stainless steel, so let's change it to CPVC, and we will solve once again. I'll not change the value of pressure to see what happens with this pressure value. So now you can see here, because we have not given some value, so we will have to go back to engineering data, CPVC. Here I'll have to give the value of tensile yield strength or ultimate strength. So let me give the value of tensile ultimate strength. This value I'll change it to 57, and this value is 82 megapascal. Now I'll go to project and update project. So when I go to model, now you can see all the results have been obtained because I gave the value of tensile yield strength. Now I'll go to total deformation first. You can see the maximum deformation is 32.812 mm. The reason is we have given quite a high value of pressure. You will have to reduce the pressure for CPVC because it's a plastic. So we'll just animate and check this result. But again, the deformation is too high. We definitely have to change this value of pressure also. So currently I'll go with the same value of pressure. You can reduce and you can see what happens. Now we'll see the directional deformation along the z-axis. It is 1.95 mm. Maximum value. Minimum is minus 11.053 mm. So you can see where it is max and min. Again we'll see along the y-axis directional deformation is minus 2.53 maximum, minus 18.314 minimum. Strain is 0.0414 maximum. Minimum is 0.000617 minimum over here. Then we will see the equivalent stress. It is 126.89 megapascal. Now since the stress generated is higher, so obviously we will have to change the pressure because we have given the value of ultimate tensile strength as 82 megapascal and this is 126, which means it is more. So obviously your safety factor is going to fall. You can see that the body is highly unsafe. So suppose if I change this value to 0.52 and solve once again, let's see what happens. You can see the total deformation has reduced to 11.22. Directional deformation also has changed, both of them. You can see the strain has changed. Value of stress has reduced. It is 43.41 megapascal. So your body has become much safer. You can see you can have 15 value also. This green is showing between 5 to 10. Here it has become much safer. And further, if you reduce the pressure to say 0.2 megapascal, obviously the pipe will become much safer. So for two different materials, the pressure obviously is going to be different. So for the same application, so you will have to use either stainless steel or CPVC based on the pressure that it is being subjected to. So with this, I end the session. I hope you understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.